Hello all. In this video and the ones that follow, we're going to take a look at a couple of tools provided by the Mediapipe library and some code that I've written that is adapted from their tutorials on how to use the models they provide to look at identifying facial features or hand positions or body poses or things like that. So I've written some code that lets you automatically run this with a video camera, a webcam, and I'm going to talk through the code for at least this first example in some detail and show you what it looks like when it runs. And then we'll talk about others as well, where really the only thing that's changing is the model and how we draw the results, but the fundamental structure of the program is going to stay the same. So let's take a look at just an overview of what this is going to be doing. So the first model we're going to look at is their basic face detection model. And so I have here a couple of examples that you can see. It basically puts a bounding box around where it identifies the face. And it's a little hard to see here maybe, but there are special features picked out on the face right here and right here, little dots that you can see. And there basically are 6 landmarks on the face that it identifies: left eye and right eye, nose, mouth. And I said left ear and right ear here. It's actually like the little front part of your ear, which has a very odd special name. But it's basically somewhere around your temples or your ears. So it identifies these and returns information about them to you. And you can identify multiple faces in an image or a frame of a video, and it will give you the same identification information for each face that it detects. So let's take a look then at the code, and we're going to come back later to look at exactly what the information looks like that you get from this model. So here is my program, which, as I said, this is pulled from and modified from their examples you can find online, and I encourage you to look at their tutorials because they're great. This is just my version of it because I wanted to make it a little more straightforward for a beginner to look at. So you can see we're importing OpenCV as before. That's what we're going to use to get the webcam frames. And we're also importing several things from Mediapipe itself. There is some change in the tools you use depending on what version of Mediapipe you have. This is the version that I was using that was working successfully for me in spring 2026. There was slight differences to what I used in fall 2025. So you just always have to be aware that things will change. The imports might change, and certainly the way you use some of the tools might change. So we have a set of import statements, and then I have here a set of constants that I'm using. These mostly have to do with how it's going to display the face, including setting colors for the little circles that it draws, but also colors for the bounding box. One of the things to remember here, if you're used to working with OpenCV versus Mediapipe, Mediapipe works with images where the color channels are in the red, green, blue order, RGB. OpenCV by default, when it reads in an image, reads it in as blue, green, red, BGR. And so we have to keep that in mind because otherwise we can mess up how the models work by passing them things where the colors are not what it is expecting. So what I've done is to write a function called runFaceDetect. I'm giving it an input which just lets me tell it whether I want to read from a webcam, default webcam, a chosen webcam, or possibly give it here a file, a video file that I want it to process. So before we get into reading frames from the video, we're going to set up the model, and this is just exactly what the website for Mediapipe's face detector says to do. It's a Blaze face short range model that's trained for us. We're then going to connect to a camera with OpenCV, and then we go into a loop that's just going to read and display the frames from the camera. So we grab a frame, if we don't have a frame, if it fails to grab a frame, it will just quit. If you're reading a video file, that would indicate you've reached the end of the file, or perhaps you have lost connection to the camera if you are doing a webcam. All right, what comes next? Well, we want to take our image that we've read in from the camera, and we want to pass it through the model, Mediapipe's model, in order to detect faces in it. We need to turn it into the right kind of data. So this is just converting from OpenCV to Mediapipe's expectations. So the first thing I do is to use an OpenCV function to transform it from a BGR representation to RGB, because that's what Mediapipe wants. So image here then is a NumPy array containing an RGB image, and that is compatible with Mediapipe tools that allow us basically to create a Mediapipe image object from it. So that's what this line is doing. It's creating the Mediapipe image suitable for use with the model. All right, the next step is very short and sweet, but it is doing a lot of work. So we are asking our detector, that's the model that we loaded, to detect faces in this Mediapipe image that we've created, and it returns a detect result. Now, I am going to suggest when, in between detecting that result and maybe displaying it, there might be other things we want to do with that data. But for right now, it's doing nothing in here. We can change that later. And it's calling a function I've created that just encapsulates the visualization parts of what we want to do. And I'm taking the Mediapipe image and I'm turning it back into a NumPy array for the purposes of drawing things on it. And we're getting back an annotated image which we can display. Again, we have to flip it back now from RGB back to BGR if we want to use OpenCV. If you were using something different like Matplotlib to display the image, you wouldn't need to be flipping the image back. I'm just using OpenCV because it's really easy to work with the webcam with that tool. This is just OpenCV code that allows me to display the frames of the image. It waits 10 milliseconds for the user to type something, and then it goes on. If you type Q, it will then recognize that you've done so and quit the program. All right, I'm not going to go into the details of all of the visualization. This is all covered. This is basically, again, just a version of the code that Mediapipe folks have provided, so you can look at that in detail on their website. So what I want to do is to run this and show you what it looks like. So we'll come up here and hit run. And then I'm going to select it up so that we can see my whole screen. All right, so here you can see it's detecting my face and it's doing so actively. It updates fairly good in real time. If I get a little closer, you can see the bounding box fairly clearly. It marks the bounding box around the face. I have changed the color of the circles to be green, but you can see that they're pretty accurate. If I do things like tip my head to one side, it does a pretty good job of keeping track of where my facial features are. If I turn my head to one side or another, it's still pretty good at detecting it. Not always perfect, but good enough. And even if part of my face is occluded, it doesn't lose track of the face. So this is something that a lot of older face detectors could not handle at all. So if I cover up part of my face, it's still fine. All right, so now I'm going to quit the program. And we will go back to looking at PyCharm again. All right, so we can run the program. It will accurately find faces and show them to us. Generally speaking, we want to use this for some other purpose. So maybe we want to extract and save the face. Maybe we want to analyze certain things about the face to see if the face is looking in a particular direction or whatever we might want to do. So we want to be able to dig in to this detect result. This is an object that contains all the information that OpenCV has found about the faces it has detected. So I'm going to go back to my notes because this is a complicated object and it's worth picking it apart carefully. And if you weren't sure what to do, like when I first saw this, I actually just printed it. I said, okay, print detect results, show me what it is. And I took a look at it fairly closely. You can also, print its type and other things like that to try to determine what exactly is going on. But I have done that for you here. So let me go to my next slide. Now I'm in the wrong place. Let's see if I can move myself. I'll just move myself over here to the middle for the moment. What I want to do here is kind of walk through the nested structure that this result has. This is typical of any of these models. They produce complicated information, and we need to be able to pick it apart. So detection result itself is an object, and within it has one variable. It's like an instance variable, belongs to the object. There may have more, but this is the one that we're interested in. It's called detections, and it contains a list of detection objects. There will be one detection object in the list for each face that it has identified. So when I was running it, I was the only face here, so it only detected one face. So you'd have a list with one thing in it, the detection object. But if you have multiple faces, then you will have, this is where they would show up. They would show up as different detection objects. So a detection object then encapsulates all the information we have about one face that was detected. And it has three parts. It has a bounding box variable, it has a categories variable, and it has a key points variable. So I'm going to take these one at a time. We'll start with bounding box. A bounding box is a bounding box object. So this describes the box that it draws around a person's face. And as a bounding box object, there's not much to it, but it's got four values in it: origin X, origin Y, width and height. So it's like the upper left corner and then the width and the height, which specify exactly where in the image that bounding box goes. You can access these just by using the dot notation and accessing the instance variable. I think I might be able to show you a little bit of this in my code. I hadn't prepared ahead of time, so it might be a little clunky. Categories is an interesting one. Because we're detecting faces here, there's only one category. It's a face. It has found a face, and that is a face. So you will usually see exactly the same category name and display name, and the index is usually the same. The one value here that is maybe interesting to us is the score. The score, in some sense, represents its confidence. How confident is it that it has actually detected a face? So it's useful to look at that in case there might be marginal faces that it's not quite sure it's actually detected correctly. So categories, there will be one entry inside this, which is just the information about this particular face. Then you also have key points, which is another instance variable, and it has exactly 6 values in it. It's a list containing exactly 6 values. Each of those is what we call a normalized key point. And the normalized key points have X, Y, and Z coordinates, and then they also have a score for how likely they are, and a label. If you looked at it, it tells you which key point you have found. Normalized key points are kind of interesting because in the X and the Y directions, it changes from raw XY coordinates in the image that vary from 0 up to the width or 0 up to the height of the image. Normalized ones range from 0 to 1. So 0 is like the left edge, 1 is the right edge, 0 is the top edge, 1 is the bottom edge. So it normalizes these key points so they're all in the same scale, no matter what the scale of the image is. And so you can think of them as a percentage across or down. We also have a Z value here. I don't know how accurate that is with this model, but it's basically in the direction of the camera. And oftentimes there's one particular key point that is being found that is defined as the 0 for the Z dimension, and then things are given as an offset from that. In my experience, they are slightly useful, but they are not greatly accurate because we're taking a two-dimensional image and we're extrapolating the z dimension from it, and that doesn't always work particularly well. All right, I'm going to go back to the code and we'll just try to take a look at this object in the code. So I'm going to add a little bit here. Hold on, I got to get to where I want to be. So what I want to do is, we said detect result is a detection object, so I want to get face data is going to be detect result detections sub-0. Okay, so then I'm just going to print out. Here what I'm doing is I'm taking the detect result object, I'm grabbing its detections list. There will only be one face in it because I'm alone. So that will, by saying bracket 0 there, I'm going to grab that face information. And then I'm going to just print its three parts, the bounding box, the categories, and the key points. So I'm going to run this again. And I'm not actually going to show you the face information because that's exactly the same as it was before. And I'm printing, which means I need to pull this up where you can see it. All right, it's printing a lot because it's doing this for every frame. So let's just stop it. And we'll take a look at what it has printed last. So what you can see here is, I should have printed this a little more nicely. This is a bounding box right there. And then this is the categories list. And then we have our normalized key points after that. And if you look at one individual normalized key point, it's it's an object, but its variables are x, y. Oh, it doesn't even include a z. Normalized key points often do, but I guess in this case they didn't bother with that because it doesn't make much sense for faces. And then it has a score of 0. And you can see it's at 0.46 by 0.41 in the image. So there's nothing complicated about accessing this data. It's just you have to know what the structure is. And if you didn't know what the structure is, then you take it piece by piece and you pull it apart and you look at what the information is. So if I wanted to do something more complicated, then I could pull this information out and do some interesting things with it. All right, I'm going to get rid of this. I don't want it there permanently in my code. Let's go back to just me. All right, so this video has looked at just the face detector, and I went into a lot of detail about the code and how it works, and I don't intend on going into quite as much detail about the future code. I'll show it to you for the other models, but it looks very much the same. So I encourage you to experiment with code, like take the information online, or if you're one of my students, you can access these code files directly and play around with them yourself and get a sense of how these work. So I hope this has been helpful, and I'm going to follow this with additional videos that talk about facial landmark, the facial landmark detector that Mediapipe has, and the hand pose and the body pose as well.